I want to talk about how we can integrate in functions that involve the natural log. Now, I put two examples here. One of them is a quotient and the other is a product. And we have, multiple integration techniques to deal with these. The first thing you always want to check is substitution, if some kind of substitution will work. And that is really what we're looking for when we do a quotient. And in fact, in this case, if I were to say that u is the natural log, which is almost always going to be the case if you're doing a quotient with natural log, the derivative of natural log is, of course, 1 over x. Now, if you think about maybe kind of a slight rewrite of this integral and say the natural log of x divided by x is the same as the natural log of x times 1 over x, well, now you can see we have a perfect match. We say, well, u is natural log, so we can replace that, and du is 1 over x dx, so we can replace that. So it really, this integral just becomes u du. And then we do the antiderivative, of course, raise the power and divide, put a plus c, and it's 1/2 the natural log of x squared plus c. So when it is a quotient, I would look to do substitution, see if that will work. Now, a product, I would do the same thing. I would check, like, a product, will substitution work? It won't, because if u is natural log of x, we already established, we're going to have this 1 over x. So that really doesn't work. So then we go to integration by parts. And of course, we have a really nice little shortcut with integration by parts where we can do the tabular integration, or, the movie Stand and Deliver called it tic-tac-toe. But that doesn't really work well for a situation like this. And the reason for that is we typically pick our u function in integration by parts to be the one that terminates. The one that if we took the derivative enough times, we'd get 0. So your inclination would be, okay, this needs to be my u, but in fact, it can't be. It just can't be. With natural log in the function, in your product, natural log has to be your u. So that means the rest is your dv. And that kind of goes against everything you think about integration by parts. But it has to be this way because the antiderivative of natural log, if we were to reverse these, the antiderivative of natural log is really cumbersome and in fact makes the problem much, much worse. Whereas here, we fill in, the derivative and the antiderivative, and we use our formula. I always call this the magic 7, where you do that product minus the integral of that product. So we'd say 1/3 x cubed natural log of x, which I know this doesn't feel like it's getting any better. But then, if you do this, 1/3 x cubed multiplied by 1 over x. Well, 1/3, okay. Now think x cubed multiplied by 1 over x is the same as x cubed divided by x. Well, that's x squared. So this is 1/3 x squared. And now we no longer have natural log. We just have a problem we can do power rule with. So I'll do that real quick. Raise the power. Divide, so it becomes a 1/9, like that. So again, if you are dealing with a quotient, I would look to make substitution work. If you're dealing with a product, check substitution, but in all likelihood, you're going to go to integration by parts and definitely make u the natural log, even though it feels like that's the wrong choice, because certainly we usually would pick the function that would terminate. Make the decision this way, line it up, and then just remember your x cubed times 1, or in this case, do that division, write down the simplified version. If this video helped you, please like and subscribe for more math help.